welcome to the next channel. So sometime I have shot a video episode on why Linux kernel is written in C and why it is not written in C++. So it is an interesting topic. I do got good feedback about the same, and I have covered various aspects about architectural aspects, how things are possible with something like C in a situation like kernel over a long period of time in terms of maintainability and stuff like that. And it's nothing wrong with OOPS. The problem is the moment you put pointers and other stuff, it's going to sort of going to make the agenda a little bit confused. So anyway, I thought today I have got an interesting comment, which is when I thought to discuss about the future of a programming language like C, and to an extent that includes C++. I'm not including C++ of UI development like C#, .NET, whatever it is. I mean, I'm not including that UI space. Even that includes GTK and other stuff. So anyway, I got an interesting comment from a viewer. As you can see, his question is why is pointer in C++ is a bad thing? So smart pointers are also efficient and stuff like that. So which is when I thought there is this illusion among system programmers and they learn generally C programming. In my time it was like we started learning C programming around second year of my college, but these days it depends. Maybe they may teach in school itself, and then college they may learn advanced topics like compiler design and stuff like that. So anyway, what happens is the moment you read something like you learn something like C or C++, what happens is one of the most difficult things to understand is how do you use the pointers, and moreover the language itself is structured in a way that you need pointers to get that low level memory access and stuff, but at the same time sometimes you need access of pointers. Every time you need to do some string operation, something very basic like string operation and stuff like that, and which is where it is both it's an advantage having pointers in C. Think about a situation like kernel code, like I discussed in that video. I don't want to open any kernel source. I'm just saying you have a lot of architecture specific code. Sometimes they embed assembly code. And other than that, kernel of course have a lot of pointer references, and even device drivers have a lot of direct device pointer references and stuff. But other than that, you have other kernel FOPs and module FOPs, function operations and other stuff. Let it be device drivers or any modules. So you have its own pointer function pointers, or else you have this structures, data structures. Again, these structures you can pass it as a pointer and stuff. So it may look, since you are coming from that background, it may look as if having pointers is an advantage or something. So which is when what happens is, right from your college or school, they make an important point that you understand the pointers very well. So they structured the exams in a way that they ask you a lot of questions about pointers, lot of confusing questions about pointers. The end objective is not about whether pointers will make you a good programmer or something like that. It is a complete stupidity. And moreover, like I replied for him, first of all, pointers itself is both good and bad when it comes to both C and C++. So the good, because it gives you that low level access, and also it can give you some amount of optimized code, okay, because you will have that low level access, and you get this call by reference and all these advantages. So other than that, the pointer itself is also a bad strategy, using excessively via any type of pointer access. The reason is, it's not about you are good in pointers, you are not good in pointers. The thing is it is going to cause a lot more trouble. As you know, when you do any code in C or Let's ignore C++ for a moment. Let's include the C, because the main topic of this video is all about the future of C. So the more you do low-level such access with pointers, you need to be careful about the garbage collection, or else freeing up your resources. So every time you do alloc and other stuff, you need to make a note that you need to free up that resource. Of course, as a systems developer, you know its importance, but I tell you, when you think about the other side of the world, when you think about the web apps, let it be scripting languages or any kind of web framework, what happens is they do build such web apps. Let it be even Java, okay, they do build such framework with a programming language like C, okay, let it be even Java JRE. Obviously somewhere it has to have that low level this thing for the JVM, so that you have that Java apps can run on top of it. So even such a JVM build, you need, of course, JVM should be built with C or C++, something like that, and top it should interpret Java and it should execute on that. So even for such situations, what happens is, although it has been used, the way world is going is towards abstraction. The more we are going towards is, since we have more powerful computers nowadays, interpreting any scripting language is not like what it has been earlier. Okay, when I was studying in the college, 1980s, 90s and stuff, I mean, even a decade before I studied in the college, one of the things you read about interpreters versus compilers, or interpreting versus compiling, or get the compiled binary, is the performance. Always we know that C code is highly performance intensive. I mean, it can perform well than any scripting languages, because scripting languages have to decode that in the runtime, okay, and then it has to do that execution of that code. So that includes Python, PHP, Java, whatever it is. So it cannot beat ever C. But having said that, since we have more and more powerful computers, please note my college system is a lot more similar to this Raspberry Pi 3. I feel in terms of processing power, it is some 30% more, but when I compare its RAM, I had hardly 32 MB of RAM, and later I got one 128 MB RAM stick, ST-RAM, not DDR, okay, and then I have upgraded my college system, so it had around 200 MB of RAM on as a whole. I mean, that by the time I disposed that system, okay, because I got also another 64 MB RAM stick, and then I have done some couple of upgrades. So if you see that way, the Pi has lot more RAM than that, and the Pi is this Pi I have put, I mean, it came with this 16 GB SD card with noobs in it. Again, if you compare this with my college system, I got my system around the year 2001 or something like that. So I got a Samsung 10 GB drive. So you can imagine, okay, this has 16 GBs in this small form factor, in this SD card like form factor. Yep. So in this kind of a small form factor, and you can imagine the entire hard disk is just 10 GB, and it is a lot more slower than this. Okay, so that's where we have gone forward. So which is why in college books and in such old theories, they do mention about lot of emphasis about compiled code versus scripts and other stuff in terms of performance. I don't deny that, but if you see the big picture, the modern systems are good enough to cope up that latency, and of course there will be a difference will be there. I'm not denying that, but you won't find much as a burden as the time goes on. Okay, after some time you feel that many things what has been done in C can be done in the top level scripting languages, and that's where the industry is shifting towards. So if you are a system software developer, and if you are in some kind of a bubble and a dreamland, you should come out of your dreamland, and you should come out of your this kind of illusion. The way the things are going forward is the more we are, whatever is done in the Linux kernel is slowly getting pushed towards the application space. So whatever is done in C code in kernel is getting slowly, pushed away, and it is slowly getting not used. It is there in the Linux kernel, but slowly those features are not being used. Instead, such similar features are getting used in the Java code, PHP code, and stuff like that. So this is where the industry is going forward. So this is the future of C as well. So C is ever going to be there, but at the same time, whatever is done in the past, slowly some of the main things done in the C code, is getting pushed towards top level programming languages. Say, take for instance me. I'm a guy who started my career as a core system software developer. I'm not a guy who done ever in stuff in any scripting languages or any kind of web development and stuff, but slowly I have ventured in, and now I'm in a point where one day I work in some kernel device drivers or modules and stuff, or else kernel component subsystems. The next day I may work in Node.js and JavaScripting and Angular and stuff, and as well my regular LAMP stack, which stands for Linux, Apache, MySQL, PHP. So this is what it is. So I'm kind of versatile. I do understand the moment you tell that to any system software developer, the moment I tell a database to any system software developer, the problem is they imagine that, just you store something in the database and it's just simple, and they don't see the big picture of the things involved, how it can impact to the society and lives. So it's just phenomenal, and that's where we are marching towards. So this is what is happening. So when I think about the future of the C, the more features which is done in the Linux kernel source, because that's the biggest C project in this world, so is getting pushed away slowly, and things are getting moved into the user space. So I can give you some couple of very good examples on this note. So the first example is we have the DPDK stack by Intel. So DPDK stack, I don't want to argue whether DPDK stack itself is done in C or C++. So let it be in any language, but the DPDK stack is an attempt to bring the entire user space stack to the user space, networking stack to the user space, so that it can bypass the Linux kernel and the packets can arrive at the user space at the highest rate, and things can be managed in the user space. So user space, as you know, you get a lot of advantages. You don't crash the entire system or something if you do some goof up with your C pointers, but if you do some goof up in the Linux kernel, it is going to crash the entire system, and you need to sit and debug, and learning a good debugging is not a solution. The big problem is, if you are having an aircraft and it is running a Linux system and it has crashed by chance, then what you will do? So it's always going to be an issue. This is the reason monolithic kernels, sometimes they don't be used in mission critical applications, like some type of missile control or some kind of nuclear stuff, controlling stuff, or some type of aircraft and stuff, because it's not reliable. It may cause some issue, it may cause some unknown issue, because it's huge kernel, and moreover, if anything happens in some module, it is going to entirely crash the kernel. And in my previous episode, or before that, I was discussing this Raspberry Pi device drivers and stuff like that. So in that, when I was demoing live, when I'm doing in the video, the system have crashed. So that's the thing. It's just a small kernel module I was doing, and I was experimenting. It's not even a module which I have completed developing. So when I was doing that, it suddenly crashed, and that's the example. So if you do any module, if you do some goof up there, if you do some goof up in the Linux kernel, it's going to crash the entire stuff. So that is why things are getting moved to the user space. So the best example itself is Intel's DPDK stack. You can go to Intel DPDK and you can learn about it. So you can find some good architectural pictures like this. You can see here whatever the Linux kernel does, the network drivers and stuff, it is getting bypassed, and the DPDK handles. So this allows us to make an extremely good routing platform, and you can have your other network stack on top of it. With that, you can make VPNs, you can make firewalling devices you can make, IDS, IPS and stuff. Okay, so that's the kind of basis of this. You can build anything on top of it. You can build some type of SDN solutions and stuff like that. Okay, so this is what. On the other side, so before I move on to the next example, see, once you move to the user space, it doesn't matter which language it is in. Okay, today it may be in C, tomorrow it may be in some kind of scripting languages, and day after tomorrow it will be in some JavaScript, and it will be a part of web applications. That's it. So that's why I'm saying you, the way it is getting transitioned is the more intelligent part is moved away out of this so-called systems part, and it is getting to the user space. And the moment it comes to the user space, few years it is going to stay in a language like C or C++. I'm saying the basic C++, not this UI. Okay, so it may stay over there, but after some time it will get moved up and it will be a part of the web apps. Okay, so this is where we are transitioning. And if you are a system software developer and if you are dreaming that web is something completely, it's only to do that UI part, okay, you are completely mistaken. So web is, you can do certain things in the kernel in web apps, and it is not always about UI part. Okay, so take away that illusion. Okay, so this is where we are transitioning. And the next example other than DPDK is I can give is Google's Quick protocol. So we can search Google Quick. Yep, you can see here. So Quick is QIC, it is not QICK. Okay, so this is Google's Quick protocol. So as you can see, I'm using this Google Chrome browser. So if I open anything in this browser, let it be any Google websites typically, okay, let it be a Google search or this, okay, things won't get passed on to your TCP based SSL or a HTTPS traffic. Instead it will be moved on top of UDP. So what they are doing is they are entirely bypassing the stupid Linux kernel's TCP stack, and they are just using UDP stack like a layer 2 service. Okay, so UDP is a transport layer, but they are using UDP as just a dump layer 2 service. Let it be not connection oriented, all this nonsense. Okay, they are not bothered. We are not bothered because we are providing the connection, we are providing the acknowledgements and reliability in the user space. So that's the attempt of Quick protocol of Google. So that's what. So this is another example. And moreover, the Quick protocol, if the browser is handling the same, what happens is the browser can be written in any language, and what happens is the core functionality of TCP is now being done in user space, and it doesn't matter which language it does. So whatever is being done in whatever language they have done in Google Chrome, tomorrow they can run these things in JavaScript also, or some kind of even Java framework also. So like that. So this is where we are transitioning. Okay, this is not possible some 15 years ago or something like that, but it is very much makes sense at this modern era, because we don't need to rely kernel doing the dumb TCP stuff. TCP itself is dumb, first of all. Okay, so if you are new to networking, again you are brainwashed by your dumb colleges saying that TCP is connection oriented, TCP is this, TCP is that, all sorts of nonsense. Okay, so I'm saying you, my videos is not about today I'm going to teach you this, today I'm going to teach you that. I cover, as you know, more like a journalist, and my videos are going to be opinionated whether you like it or not. Okay, so if I go behind the so-called YouTube likes and dislikes, then I need to change my tone. If I need more likes, then I need to talk like any typical way one covers. But the role I play in the society is more like a guru. So guru do things and they have their own conclusions after an extensive research and extensive know-how and stuff. So this way I'm saying you, what happens is when you do things like TCP, first of all, if you see the history of TCP itself is some 50-60 years old, and anything which is that old in technology is going to be having some disadvantages and advantages. We all know what is the disadvantages of IPv4 protocol, and we also know why it is still being used and not getting transition to IPv6. IPv6 is good in some ways, but it is difficult in terms of scrapping away all the old hardware and getting into IPv6, and moreover the cumbersome IPv6 addressing stuff. But at the same time, IPv4 is simple, but again we need to deal with this nonsense of NAT and other stuff because it is not equipped to handle this many people in the world. Okay, IPv4 is not done for that, first of all. Similarly, TCP is also done ages before, and it is done for that time some requirement, but it is highly appreciated because they had that insight. Even after 50 years we can still use TCP, but it is having lot of drawbacks, and unfortunately you put something like TCP in Linux kernel. One of the worst things happens with TCP in a kernel is TCP, whenever it receives out of order packets, okay, it tries to make them it does arranges these in the proper sequence and then sends it to the user space. So if you have a TCP socket established, what happens is when you receive the packets, and by chance if they are out of order because there is some intermediate firewall or some device in the internet or your networking infrastructure, and it has goofed up that packet order. So if you get it in a different order, the kernel have to wait, the TCP stack in the kernel have to wait, and if it gets out of order packets, it will collect them in some buffers, okay, and then once if it collects, and it will jumble these things and assemble them in the right order and then pushes it to the user space. So it is good in terms of theory, but you imagine kernel doing this nonsense. The moment the kernel handles any type of long big buffers, it's going to put lot of overhead in a kernel. It is good to do sometimes these things in the user space, okay, than something in the kernel space. Okay, so if kernel is well optimized for doing these things, then you should have MySQL or some database architecture in the kernel itself. Why don't we do in the Linux kernel? The reason is kernel sucks in terms of scalability and certain things. So I'm saying that is why the moment you push such logic to the user space, the moment you use something like a dumb UDP, which means you are shutting its ass and you are telling the kernel just do this, and all the intelligent stuff I do it in the user space. The moment you do that, you don't need any extensive C code for UDP code. So this is what, let's assume the entire internet is transitioned from TCP to UDP, and they are dealing everything in user space like this quick protocol or something. So now what happens is you have lot more less code in the C versus things are possible in the upper layers. So that's where it is going towards. So that's why the modern IoT and as well as this data sciences and machine learning and other stuff, they cannot do something that scale in a language like C. C really, C code really sucks in terms of doing such, large scale, processing data. I mean, I'm not saying it cannot process. I mean to say such large, scale of cognition is required. I'm not saying computation. I'm saying cognition is required. Cognition is you do something and how do you understand that results. So that's what is cognition is. So okay, so if you take for instance, I can give an example. See, if you go here, this is my YouTube studio, and if I take you to this analytics, YouTube shows in this all these graphs to understand what my channel is doing. So this is an live view. You can see here it will show here updating live and stuff like that. It is a live view. So say if you don't have YouTube channel, so this is completely new to you. I'm just showing you this is what it is happening. You can see here live, it is these many videos are getting watched for past 1 hour, and if I click here see more, and it is going to show the live view of which videos, top few videos is getting watched and stuff like that. So again, it depends on the channel to channel basis. If you have more like cooking shows and travel videos and stuff, they may get lot more views than a channel like mine. So to get something like this, what is more needed is cognition. It's not just data processing. We need data processing. Of course, the Google servers are going to run in Linux or FreeBSD, something like that. Of course, they are going to get that. And kernel gets it through device drivers, we all know that. But other than that, the actual meaningful data extraction and the data processing is done in the top layers. Okay, so that's what is my point. The more emphasis in past 15 years is all about this transitioning. This is what is happening. Okay, 20 years back, some couple of decades back, the main importance is all about whatever have been done manually is computerized. So that's the focus in the entire world. Okay, things are done in the manual fashion. Let it be post offices, let it be some travel ticket booking system, let it be even hotel reservation and stuff like that. So now we have computerized everything, and now we have these apps through that you can order anything you want, food, whatever it is, services you can order. And so we have transitioned. So when a platform like this is seen, kernel plays a very small part. Okay, is what is my point is, of course it is there in all the devices. In all smartphones we have Linux kernel or something, some operating system, and then you need of course low level components. But I'm saying you, the main focus is, once it is done, okay, the main focus is all about what happens in the upper layers, and that's where it is causing the significance. So that's where the trend is shifting towards. So the future of C is going to be always there. I mean, C is always going to be dominant, but at the same time, the more important things C programming language did in the past, I doubt it is going to be there. Things will be pushed to the upper layer ecosystem. Okay, so that's what. So things are this is a good example. So we cannot try doing something in the kernel or something like that. So when I talk about it with any system programmer, the big problem is they fail to understand this aspect. And when I talk about the importance of system software development to any guy who is working in web apps or web related platforms, they fail to understand. So this is the sort of gap we have in the industry. There is one guy who sits at this extreme end, and there is another guy who sits at that extreme end. Both fail to understand their importance. Both are needed, but at the same time, things which are done in the past in a certain way is getting transitioned. And that is why we will see a lot of trends in the job market. You will see a lot more things in the future. There will be a lot more openings for other aspects, something like this, rather than someone who is sitting and doing some core system software developer. So this is what is the thing it is happening in the market. So think about this. And when you are a core system software developer, understand these aspects. There is more and more, this, trend reversals is going to happen, and it is going to shock you in your career lifetime. Okay, so this is what. So since I work in both the ends, I appreciate both the parts. Okay, I like the low level aspects of Linux kernel code, but at the same time it is not going to do anything which is cognitively possible. So if I need a lot more cognition, then I do it in the other side, where I get the fun of doing it, and I see the actual big picture, because I can really understand what is going on, okay, with that given data. So let's assume I do a network stack. I got the packets, but I got the data via packets, but where is the cognition part? Okay, you have given you something is given to you. What you are making out of it is going to make sense. Okay, it's just like a college student who just have books, but he don't study well, versus a top performer is poor. He may lend and borrow books, but he can get good scores. So it's the difference like that. Okay, so think about these aspects. If you are a core system software developer, explore the possibilities in the top layers. And if you are a guy who is working in web applications and stuff, understand little bit of aspects of the low level system as well, because these aspects and these principles may help your career as well, because you can sort of replicate these things in your top layers as well. Let it be Java or Python, PHP, whatever. The things which are done in low level system software programming can be replicated and can be done in a similar way in your programming methodology. So hope you enjoyed this video. If you have anything to discuss, be in touch via mail. I'm not saying that comment is bad, I'm just saying that it's a sort of perspective. It's you need to see the big picture, and I'm not saying pointers are bad, I'm not saying pointers are good. It has its own advantages and disadvantages, and we need to live with that. Okay, so it's what it is, and maybe we don't know, something may come in future and it may dominate, and it may even take over. See, who knows actually. Okay, so if you have anything to discuss, once again, like I say, be in touch via mail or post your queries in the YouTube comments. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.